Hello and welcome to video number 1 in the Introduction to LogicWorks series. LogicWorks is a schematic capture and digital simulation system. It is ideally suited for teaching digital logic and is in use by universities, colleges, and high schools all around the world. Before we start building our simple circuit, we will go over some of the elements that are currently visible on the screen. The main window in the center is where we place our parts and interconnect them with signal lines. The window below is the timing window, and this is where the results of the simulation will appear. The window to the right, the floating window, is the parts palette, and it displays the contents of the currently selected library. In this case, DemoLib is selected. We could, of course, select any of the other libraries that are currently loaded. The DemoLib is a small library only containing about 8 or 10 parts. The other libraries contain considerably more parts. Anyway, back to the DemoLib, just to keep things simple. And over here on the left, this particular floating window is our tool palette. And we're currently using the pointer tool, but there are 4 or 5 other tools. LogicWorks tries to remain modeless as long as possible, so we spend most of the time using the pointing tool. But there are tools to delete signals or devices, also tools for naming things and drawing signals or buses, zooming in and out and such. This floating window here is the control palette for the simulator, and we can stop the simulator, start it, adjust its speed. We can also lay down probes or zoom in or zoom out on the timing window. And triggers are also possible, which we'll go into later. Anyway, I think that covers all the windows. So let's get started. We're going to build a very simple circuit. So let's start by picking this 74164. So we double click on it, and we then move the mouse out into this main window area. And we'll click down once to place it. Now we stay in placement mode, but so that we can place additional copies, but in this case we only need one, so we terminate that mode by hitting the space bar or the escape key. I prefer the space bar as it's a little easier to find. Okay, now what we want to do is go over here and select an exclusive NOR gate, so double click, move the mouse out. Now we're going to butt the 2 pins on the gate up against the 2 pins on the upper right hand side of the 164. So we'll go up and connect them. And I'm not sure if it shows on the video or not, but the pins flash momentarily just to indicate that they were connected. So again, we terminate placement mode by hitting the space bar. Now I don't particularly like the gate being that close, so I can move it by just clicking on it and dragging to the right. Again, we stay modeless by just assuming that if you click on something and drag it, you want to move it. Now I'd like to feed the output of that gate back into the input of the 164. So I'm going to draw a signal line. Now when you click on the end of a pin and drag, it assumes you want to draw a signal. So we do that, let go, and we click and drag down to here. And we can click and drag off the end of that pin and up to here. And we've got ourselves feedback. Now I want to also place 2 other devices. So let's go over here and pick up a clock. Or actually a switch in this to start with. So double click on that, move over here, click so the 2 pins connect, and terminate by hitting the space bar. Go over and grab the clock, double click, move over here, and click. Terminate by hitting the space bar. Now, things are a little cluttered, so let's adjust things a little bit. Once again, we move things by clicking and dragging, so we'll move that clock over here. And the switch is a little different though. Default behavior when you click on a switch is to change state. So to move it, you have to hold down the shift key. So shift click on the switch, and we'll move them both out a little bit. Okay. Maybe I'll move that clock a little bit along like that to move this line over a bit. And I'm still not happy, so hold the Shift key and click here and move it out. Okay, that looks pretty good. Now the simulation is running, but we're not seeing anything because none of the signal lines are named, and only named signals appear in the timing window. So let's go into name mode. We go over here and click on this tool. And when we move back here, we'll see a pencil icon. So what we'll do is come down here and name this one. Just click and release, and LogicWorks will name it and place it where it thinks that you'd like it. And I don't like the name, so I'm going to type in a new name. So CLK, or pardon me, CLR, and hit return. Now as soon as we do that, you'll see that the timing waveform starts appearing, but it's pretty uninteresting because it's stuck in the low state. Let's go and name the clock. So click on there and release, type CLK and hit return. Now we got something interesting happening. But we'd really like to see what's going on in this particular signal up here. So click on it. In this case, don't release, just move the mouse and release and type in feedback. So that demonstrates that you can place the name wherever you would like. Most of the time LogicWorks does a pretty good job. So now you'll see that we have another line called feedback. We'll go down here and unhighlight everything by clicking here. And but nothing too exciting is happening on feedback because the switch is low and therefore clearing the device. So if we click it, it'll switch to high, and we get some results on the timing window there. You can have a good look at feedback. So why don't we go over to the simulator control and play around with it a little bit. So one of the things we can do is make the signals zoom in so that they're easier to see. So as you can see, I've zoomed in and things fly by a lot quicker because we're displaying less actual time units. And we can go the other way as well by clicking this. The other thing we can do is we can stop the simulator by clicking on the little guy who's sitting in the chair, so then the simulator stops. To start it, we click on the man running. We can stop it in single step the simulator, or we can just adjust the speed so it goes a little slower. Each time we move it closer to the running man, it gets faster. Closer to the chair, it gets slower. We can also restart the simulation right from the beginning by hitting restart. Now, one other thing to look at is back over in the demo lib, there's a binary probe. So you can place probes around the circuit. In this particular case, we'll put a probe out here and monitor. Again, we terminate by hitting the space bar, and then we're going to connect those two up. And we can monitor the output of the QA pin. As you can see, or hopefully you can see in the video, that the probe displays the results here. Now, we can also change the delay through a gate, and we do that by selecting the gate and going up to the Simulate menu and say Simulation Parameters. And we can increase the delay through the gate. So if we hit the plus sign, it'll increment the delay, and minus sign decrement, or we can just set it to 1 or set it to 0. In this case, I'll set it to 4. Now it's an event-driven simulator. You can assume that the numbers are nanoseconds, but of course they're just numbers. Okay. Okay, I think that's probably enough for the first video. So what we'll do is we'll go up and save this design. So save design as, and we'll put it on the desktop, and we'll call it tutorial number 1, or maybe just tutorial 1. Okay, that's it for the first video. Thanks for listening, and do come back and check out the rest of the series. Thank you.